Could the interior of a spherical universe be flat? At this point, this is weirdly kind of a language problem. Because, when we're describing the shape of the universe, we're talking about how the space of the universe operates. So the space can be defined by parallel lines, so it's flat. The angles of a triangle add up to 180 degrees, so it's flat. Any distance would eventually loop around to itself, so it's a torus or similar shape. So again, we're just sort of describing the properties of the universe. There's a way you could say that the universe is spherical if you said take any point in the universe, would it be equidistant from that point in all directions before it started looping back around on itself? A universe built out of an equal distance from a singular point could be described as spherical. But it's worth noting that's describing something as spherical in a different definition of the topological definition of spherical, which is usually what we use when we talk about what shape the universe is. Using that definition, it doesn't necessarily mean that the universe is not toroidal. In fact, it would mean that the universe is flat and is toroidal and is spherical all at once, just in different ways. So I think what I'm trying to say here, as soon as you start talking about the inside of a sphere or the inside of a torus, you're not talking about the same thing. Because when we use the model of a torus, we're having a 2D surface stand in for the 3 dimensions we exist in. The universe wouldn't be 2D, it's 3-dimensional, it's just that we're using a 2D representation to understand it. So there wouldn't really be any inside of the sphere. Because going inside a sphere is moving in a higher dimension, because remember, the 2D surface is standing in for the whole of the universe. So the surface of a sphere is 2D, but to go inside you need to go in the 3rd dimension. So in this analogy, you would have to move in the 4th dimension to go inside a spherical universe. But again, just the laws of geometry do not point toward our universe being a sphere. So you would be going inside a toroidal universe, and then you would be describing distance as spherical, and this is why, when we talk about stuff like this, we don't like mixing terms. We keep everything to the topological definition, and we basically say that the 2D surface of these models that we're showing you is a stand-in for a 3D construct. It's just showing how points in space relate to each other, it's not showing the actual shape of space.